Dielectric heating. This process occurs when material absorb microwave energy due to their dielectric loss, which is quantified by the loss tangent, the ratio of the imaginary to real parts of the material's dielectric constant. For efficient heating, a loss tangent value of 0.1 or higher is typically required. Different material respond in different way. In polar molecules like water, microwave cause the molecules to rotate rapidly, generate heat through friction. In materials like salt solutions or certain ceramics, ionic conduction creates heat as charged particles move and collide. And in conductive materials such as carbon or silicon carbide, Joule heating occurs as electric current flow through them. One major advantage of microwave heating is that it heats materials volumetrically from the inside out, unlike conventional methods that heat the surface first. This leads to faster, more uniform heating, which is highly effective for a wide range of applications. Therefore, unlike conventional heating, which transfers heat from an external source through convection, conduction, or radiation, microwave heating generates heat internally via electromagnetic waves. This enables faster or more uniform and energy-efficient heating. Microwave heating also enables selective heating, where specific components are heated selectively according to their dielectric properties. This capability is a significant advantage in processes like material synthesis, drying, and advanced manufacturing. Here you can see the microwave technology advantage overview. Long story short, microwave heating is a changing industrial process with its advanced efficiency. Unlike traditional method, it converts energy directly into heat, reducing energy use by up to 85%. It also offers precise control, faster processing, and a lower carbon footprint. Oh. Should have a problem here? Sorry. Okay, sorry. What is plasma? Plasma is often referred to as the fourth state of matter alongside the solid, liquid, and gases. It's created when a gas is heated to exposed to a strong electromagnetic field, causing electrons to break free from atoms, creating a mix of charged ions and free electrons. There are different types of plasma, including thermal plasma and non-thermal plasma. Plasma can be found in nature, such as in lightning, flame, nebulas, and all stars like the sun. In industry, plasma has a variety of applications. It's used in plasma cutting for metal work, plasma arc welding in manufacturing, and plasma-based sterilization in medical field. Cold plasma is also crucial in semiconductor manufacturing and decontamination systems. One can say a long story about this important in both nature and technologies. Plasma can be generated using microwave energy. Microwave plasma torches use high-frequency microwaves to ionize gases, creating plasma that reaches extreme temperature. Here you can see a 100 kilowatt microwave plasma torch developed at Frick-and-Muller Microwave Technology Company, boosting an impressive 85% energy efficiency, a unique achievement in the field. Compared to traditional plasma torches, microwave plasma offer lower consumption, more stable plasma generation, and a purer plasma environment, making it ideal for chemical process like gas conversion as it operates without electrodes. Microwave plasma torch offer a highly efficient, precise, and environmentally friendly alternative to conventional burners. Their standout advantage is energy efficiency reaching up to 90% while significantly reducing operational costs. Unlike traditional combustion, microwave plasma produces no CO2 emission or pollutant, making it a cleaner, greener choice. However, some challenges remain. Advanced material required, limited scalability, complex operation, higher initial cost. Microwave heating and plasma technologies offer major advantages in material processing. They can cut processing time by up to 50% and reduce energy consumption by 40 to 85%, making operation faster, more cost-effective, and environmentally friendly. These methods also allow for better process control. Plasma enables chemical reaction that were previously impossible, while in microwave heating can selectively target materials based on their dielectric properties, heating from the inside out. This lead to more precise control, improved efficiency, and even the potential to develop new materials. The result, higher product quality with greater consistency and performance. Beyond the chemical advantage, microwave and plasma technology deliver strong economic benefits. They help lower operating costs through higher energy efficiency and faster processing, which reduces maintenance needed thanks to fewer moving parts and non-contact heating. Downtime is minimized. This system also boosts productivity, allowing more output in less time. And when you combine all these factors, the return on investment is impressive, often within just 2 years. In the end, worth mentioning that microwave technology has a vast and growing range of application in various industrial sectors. Microwaves are becoming increasingly internal to modern industry. As the field continues to expand, new applications are emerging along with innovative material and production methods. Tomorrow, we will discuss some success stories of microwave implementation on an industrial scale. Thank you for your attention. And if you have any discussion point for current heating challenge or potential applications or implementation concerns, let me know.
Great. Thank you very much, Said. We will have the Q&A session at the end of this webinar for anyone who is interested, so we will bring it up again. Next, I would like to invite Mr. Veronesi regarding his slides. Paula, can you share the screen, or do you want me to do it?
It's up to you. I don't have strong animations to show, so it's
Okay,
up to you.
so please go ahead and present so you can move along. Thank you.
So I will present myself.
Yes.
Okay, just a moment.
Yes, of course.
Full screen. I'm almost there. So now you should be able to see my screen in full screen. Okay. So we have spoken with Said about the advantages of microwave heating, but now we are entering more on details on how you can generate microwaves and what are the benefits. In particular, we are going to focus on the difference between solid-state generators and magnetrons. Well, these two pictures that you see here is what the artificial intelligence thinks about solid-state generators and magnetrons. Yes, it's completely wrong. The pictures has nothing to do with reality. And this is good news because it means that it's something that still it's not quite known and widespread in the audience. But basically, you're all familiar with magnetrons because if you own a microwave kitchen oven, it's operated by magnetrons. And probably you have noticed during the functioning that it operates based on duty cycle. So it's an on-off procedure of emitting microwaves. When it comes to industrial scale generators, of course, we can no longer use this quite simple approach, and usually we have more complex power supplies, like switching power supplies, which allow for the continuous variation of the emitted power by the magnetron. But recently, we had the possibility of having also a microwave generated by solid-state generators. Actually, it's not so recent, but only recently this application came with, let's say, higher power, and so the possibility to be applied not only to the communications, but also for heating. What are the main differences? Probably if you have a look at the picture on the left, you will notice that we have in black line the spectrum of the magnetron. And here it is a magnetron which should be centered on 2.45 gigahertz, which is one of the ISM frequencies that Said mentioned. But as you can see, it's wide banded. So the emission is not occurring at only one frequency, but it's occurring at different frequencies, of course, not that much far from the central frequency of 2.45. But nevertheless, this is quite different from what happens with a solid-state generator, which here has been depicted by the red line. So practically, it means that you can more or less operate at a very precise frequency. And this maybe it's even clearer in the picture in the right when you can see the two spectra of a solid-state generator and of a magnetron. So solid-state generators are narrow-banded, and moreover, their way of functioning is exactly the same that we use when we model microwave heating. Usually, during modeling, we tend to excite microwaves at a given frequency rather than using this complex spectrum for excitation. And we have advantages from industrial point of view of processing. That means that we can shift frequency. So that line, the red line that you see in the picture in the left, it can be shifted rightwards or leftwards, so at higher or lower frequencies, depending on some requirements that we have. For instance, maximizing efficiency or generating specific heating patterns. And this is practically not feasible with magnetrons, so it's a huge advantage. And moreover, the frequency of the generator, solid-state generator, can be swept. So going back and forward among two frequencies, so to provide a better heating homogeneity or to select the most convenient frequency to heat the load that you want to process. In practice, this control is quite easy. Solid-state generator is much more difficult, if not impossible, using standard magnetron sources. And we have other advantages, and that's why we are addressing the topic of solid-state generators here, because in the near future, we are expecting to have more and more use of solid-state sources compared to magnetrons. Why? For instance, for lifespans reasons, a solid-state generator can last hundreds of thousands of hours. And instead, magnetrons usually are rated for 6,000 hours or up to 15,000 hours, but they have to be carefully operated. So much longer lifespan, and also something concerning safety, because magnetrons usually are fed at kilovolts voltage, while solid-state generator operate in DC current and only 30, 50 volt. So it's much safer, and the systems are usually easier. Moreover, they do not suffer from vibrations. Magnetrons as an heated element inside, which emits electrons. Solid-state generators basically have oscillators and amplifiers. So it's a more robust source compared to magnetrons. Moreover, solid-state generators are easily turned on and off. Instead, magnetrons usually require some preheating time. Sometimes it can reach 1 or 2 minutes for large power sources. And so this is also a drawback if you want to implement processes where you want to rapidly heat and then turn off the generator. In case of magnetrons, you have to keep the filament hot and simply setting the on and off time consequently. So it's a different way of operating. But probably the main advantage when it comes to industrial processing is given by the possibility of changing not only the frequency, but also the phase of each generator that you're using. What's the meaning? In magnetrons, usually when you operate magnetrons, they start with a random phase. So if you have 2 or more magnetrons, you don't know if they are going to interfere constructively, destructively, or partially, because each one will start with its own phase. So unless you split the power from a single magnetron of different sources, it's practically impossible to play with the phase of the microwave sources. Instead, with solid-state generators, you can change the phase. And the practical consequence, you see it in the animation that's in the middle of this phase. It looks like something is turning. It's a pizza, by the way, but it's not turning. Actually, this pizza is staying there, leaning on its plane, and we are simply shifting the electromagnetic field by changing the frequencies of the 2 microwave generators, which are solid-state ones, emitted by these 2 microwave sources. So you see this huge advantage of moving the fields, and if you can also monitor temperature, you can move the field so that you can, let's say, focalize the heating to certain regions. This is quite clear in the picture that you see here on the right, where simulated and experimental results show you the possibility of differently heating 4 loads, identical loads, by changing the frequencies of the microwave emitters, solid state, that you see at the top of this small furnace. So these huge advantages that we see in solid-state generators are probably likely to open a new era for microwave applications. For the time being, one of the main drawbacks is the lack of availability of high-power microwave sources. So for, let's say, energy-intensive processes, it's still quite difficult to use solid-state generators because you must use a lot of them, and usually the cost per kilowatt power installed is higher compared to high-power magnetrons. But nevertheless, this is an interesting perspective for the future. And moreover, these controlling capabilities that we have on solid-state generators can open also the road for a better process control, because, for instance, by properly controlling where heat is generated, you can avoid one of the main problems when heating microwaves loads which have a loss tangent which increases with temperature, which is called thermal runaway. So the fact that you are generating heat in one portion of the load, and the more it gets heated, the more it absorbs microwaves and so on. So for instance, here you see a cube, a ceramic cube, where the inner part was melted and then poured out. So we can avoid these phenomena by properly controlling temperature, and this can be achieved by phase shifting or shifting the operating frequency of the solid state generator, which is something that it's not useful, it's not feasible with conventional magnetron. So I hope this raised some interest with this new technology, and I will leave the stage to my colleagues to continue with the webinar. Just let me stop the sharing.
Great, thank you very much. Next one is our project coordinator, Maria, who will present an introduction to the METAWAVE project. So, Maria, whenever you're ready, go ahead. Thank you.
You're muted, Maria.
Thank you, Zari. Yes, so I will present now an introduction to make my METAWAVE project now that we know a bit more about microwave technologies. If I click next. Okay, so METAWAVE is a project that started in January 2024, so a bit more than 1 year now. It's a project of 9.5 million euros funded by the European Union. We are 19 partners. Well, now we are 20 partners from, I think, 7 different countries in Europe. And we have 3 industrial use cases or pilots that will demonstrate different microwave technologies that my colleagues have presented today. So there are 6 main specific objectives. The first one is to develop a new design methods and consolidate a process for the introduction of microwave technologies to replace conventional fossil-based heating systems, which will provide one of the key exploitable results, that is METAWAVE simulation-driven design. The second objective is to optimize industrial heating processes and reduce the energy demand by integrating novel digital technologies that will provide another key exploitable result, that is the microwave digitalization process. The third objective is to fully capture the potential of renewable energy integration and energy flexibility by powering the microwave-based heating system from digital virtual power plant that will provide another result, that is a flexible energy operation decision support tool. The fourth specific objective is to deploy and validate an integrated modular microwave heating system combining high energy efficient breakthroughs targeting increased productivity, and we will have as a result a microwave heating integration kit. Then we have another objective to ensure the techno-economic feasibility of the METAWAVE system and pave the way towards a wide acceptance, technological adoption, and upscale. And we will have as a result a sustainability and adoption strategy. And finally, to convincingly demonstrate the METAWAVE system in a distinct industrial environment towards the acceleration of the approach to market readiness. And the result are these METAWAVE demonstrators that I will present afterwards. We have also 13 main innovations. The first one is a microwave plasma torch for porcelain tile firing, like using technology that Said explained before. Another innovation is direct microwave heating with hot air flux for aggregate heating. Also, we have a direct microwave and induction heating for carbon anodes baking. Those are the 3 main demonstrations. And this demonstration will also have other innovation integrated, that is the geopolymeric microwaves refractories. They will also be integrated in some of them nanostructure additives to improve the microwave absorption. There's also been an innovation about selection charts for design of successful microwave processing and applicators. And then to monitor the prototypes, we will have another innovation, which is multiparametric and multi-optic fiber optic sensors and thermographic using SWIR and multispectral cameras. We are digitalizing the prototypes, the designs that we propose. So, and as a result, we will develop reduced order models of these novel heating processes. And as well, we will implement data-driven optimization of the heating processes to help with the control. We will also develop a virtual power plant for hybrid centralized distributed and autonomous energy flexibility that will include renewable energies to make the whole sustainability. And increase process energy efficiency with multi-criteria optimization. And finally, a distributed process control system of the prototypes. So this is the main concept of the project. So as I was mentioning, we will do some material development together with the simulation-driven design. We will develop the microwave-based heating system prototypes, which are the three main technologies. We're also developing different types of sensors, as well as a data infrastructure, together with a distributed process control system for these technologies. And in parallel, we are developing hybrid process digital twins, a built-up power plant, including renewable energy storage and flexibility, and a common user interface to provide the user with the information. Transversal activities are a life cycle assessment and life cycle costs, training activities such as the one today, and modules, innovation roadmap, a replication and transferability assessment, and the METAWAVE readiness. And all this, as I was mentioning, in 3 demonstration plans that I will present afterwards. So the main outcomes are to increase the energy efficiency of the energy industrial processes by reducing energy usage by at least 30%, to enable the potential of an increased use of renewable energy, to enable the techno-economic feasibility of novel technologies and processes validated and demonstrated at suitable scale against industrial processes state-of-the-art, and to contribute to achieving the European Union climate neutrality goal and becoming independent from fossil fuel as stated in the REPower EU plan. So the 3 industrial cases, the first one is in the ceramic sector, is a porcelain tiles firing. The current conventional heating process is continuous with a process temperature of 1,300 degrees, and they use natural gas. The microwave technology proposed here is a plasma torch based on microwaves, and the technological benefits is microwave heating. This microwave heating will increase energy efficiency, will reduce emissions, and also boost productivity, making the process more sustainable and hopefully a bit more flexible. And the second industrial use case is in the asphalt, is for the aggregate heating that is required for asphalt production. The conventional heating is continuous with a process temperature of around 1,400 with a flame that burns low sulfur heating oil. We propose to substitute it with a direct microwave heating plus a hot air flux. And the benefits will be a much more energy efficient process that will increase productivity and significantly reduce emissions, and also increasing the overall sustainability. Finally, the last use case is in the aluminum sector, is for the anode production. Currently, the anode production is in a batch process with a process temperature about 800 to 1,000 degrees, and they use natural gas plus hydrocarbon volatiles. And we propose to substitute it with a direct microwave heating together integrated with induction heating. And the technological benefits will be these advanced heating systems will increase productivity, lower the energy use, and reduce emissions, supporting therefore a greener production process. So finally, just briefly the methodology. So as I mentioned, it's a 4 years project. We are now finishing the first stage, that is the consolidation and design, in which we have gathered the user requirements, heating system design, and also started with the digital design. And we're just starting with the developing and prototyping. We have initial designs of the prototypes, and we will soon start the manufacturing processes and the sensors as well, and techno-economic feasibility. And then towards the end of the project, around month 32, the prototypes will be installed in the 3 use cases, and then we will perform the validation demonstration activities along with some other transversal activities such as life cycle assessment or the road mapping. And that's all from my side. Thank you.
Great. Thank you very much, Maria. We move on to the next session where Mara from Crete will be presenting about the assessment of the current readiness regarding the company. So Mara, please go ahead with your session. Thank you.
Yeah, thank you. I will try to share the presentation, and you will tell me what you see, because my computer is not that friendly with Zoom, so I'm seeing weird things sometimes. Okay.
Okay, we can see the presentation. I think it's perfect. We're seeing it on full screen.
Okay, great. Okay, so as mentioned, I'm Mara Corbella from Crete, and we are a company in charge of evaluating the performance of the companies and proposing, suggesting them ways to improve this performance. So that's why I was asked to take charge of this specific training and section. The focus will be on how a company can understand if it's ready for improvements, technology adoption, innovative technologies adoption, or if something needs to be done in order to improve and to increase the performance. So I thought about this project in which we are partners. It's called SMURF, and the acronym means literally SMEs ready for the future. So I thought it was a good kickoff for the discussion. So this project, very briefly, started in 2023 and will end next March, so in 2026. On the map you see the partners involved in the activity. It was a project funded by the Interreg Central Europe program. And the objective, the aim of this project was specifically to help and to support the SMEs in this transition, this process for the improvement of their performance and transforming into companies and SMEs, in this case, ready for the future. For doing that, okay, first of all, where we started. These are some information and data from the last European Innovation Scoreboard. So we started from this knowledge that SMEs often have challenges and face challenges when they need to adapt to a changing market and to the request for increased competencies and performance. Only a small portion of the SMEs at European level has recently introduced new products or has increased the quality of the products that they already offer. And within the SMEs at European level, only the 12% of them is interested in introducing and applying, or has already applied, a process of collaboration with other entities, with other companies, in this sense of open innovation and sharing of knowledges and competencies. So this could be constraints when the SMEs needs to grow and to increase their performance and the quality of the products and services. So what we have done so far in the SMURF project is that we have, starting from this basis, we have analyzed the existing tools that you can find online for the self-assessment of the performance of the company. We have tested more than 80 of these tools and tried to prepare and design something that is different and yet inclusive of what we have seen in the existing tools. We have analyzed some best practices in our national domain and also at international level, and we have interviewed 16 companies that can be considered as best practices in their respective fields. And then we have organized 4 training webinars that should be already online and available related to the pillars of the project. I will briefly tell you what we are discussing when we talk about pillars. So in order to evaluate the readiness of the SMEs, we have focused on these 4 pillars. So innovation culture, meaning is the company adopting an innovation-friendly approach? If the company is in some way driven by the open innovation culture. Then the digital manufacturing, which of course is not applicable for all the SMEs, but at least for the one in productive context. So if the company is already integrating in the production innovative technologies and solutions, if there is a knowledge about the trends at international level, and if the company is interested in following these trends. Open innovation 2.0 and sharing economy. So if the company is already renting or sharing knowledges and resources with other companies in the field, in the context, or if that's something they are willing to do but don't know how to move in the international scenario. Green and circular economy, and of course sustainability, which I believe is the pillar more related with the METAWAVE project, considering the technologies that we are developing and trying to integrate. So of course the attention and care about environmental and sustainable topics to be adopted in the production process. Okay, so these were the features, we can say, that we focused on for each of the pillar, meaning that to understand if the company is already performing in that specific pillar, we tried to identify sub-contents, like in this case, sections of the specific pillar. So in this case, for instance, innovation culture, we have collaboration and communication within the company, leadership and relations, meaning the relationship among the leadership, so like the CEO, for instance, of this small company and the employees working for this CEO. These are other examples of the features for each pillar. I don't want to go into detail, but I need to show you these, yes, to make you understand that for creating this tool that I'm now presenting, so this self-assessment tool for the companies, we started from the pillar. We identified the subsections, so the features for each pillar. And in order to assess the performance of the company in each feature, to then go to the pillar, we identified some key questions and potential answers. And the result was this tool. Now I don't want to focus on this slide because it's a lot. I will briefly tell you something about how the tool is structured. It's divided into 2 steps. Of course, the company needs to register on this platform to access the tool, but information requested are like few. And then the questionnaire starts. The first step is more general, I would say. So it's easier and it's quicker. It's 10-15 minutes. For each pillar, you have 10 questions related to the features and then to the pillar. And I said they are more generic. After this step, the company will get a first output, the first evaluation, which is mostly graphic in radar charts, to see in a graphic way how the company is performing in each of the pillars. After that, the company can choose to go to the step 2, so the second part of the evaluation, for which the company is able to choose among the pillars, meaning that if a company is not related to production, probably the company, the responsible, the user, will not choose the pillar related to digital manufacturing. They will focus on open innovation or innovation culture. After choosing, the company will fill only the questions related to the pillar they have chosen. If they want to do the 4 pillars, of course, it's not quick, because as you can see, it can take up to 45 minutes. But at the end, the company will get a tailored set of instructions and suggestions on how to cover the gaps, we could say, in the pillars they have chosen. Meaning that if in one pillar they are performing really good, they will not get recommendations or maybe just slight suggestions. If the company is performing poorly in the pillar for sustainability, they will get recommendations for mentorship or specific training courses or other activities that can help them to improve in that field. Okay, these are screenshots of the tool. I should have sent something in the chat. It's the link for the registration page of this tool. We have just concluded the development of this tool, so we are in the testing phase. That's why I'm asking if you are willing to at least try the first step or to take a look at the performance of your company. You can register to the tool and take the questionnaire. And also I wanted to show you briefly directly by, you still see my screen, right?
Yes.
Okay, great. Of course, I am already registered, so for me it's easier. But I wanted to show you how it's working. So basically, it's very easy. After you register, you just have to create a new submission, and then you can start with the filling of step 1. As you can see, the questions are quite detailed, but there are a lot of options, and of course, the not applicable option is always available, since not all the topics are related to the companies, or at least not to all type of companies. Of course, I have the auto-compile because it's still in the testing phase. So for me as administrator, it's available, but you will not see it. And after filling in with the auto-compile, you have the possibility to change the answers. Then after submission, this is what you get. So okay, the results, visual graphics, so for innovation culture, the performance, for all the pillars, the performance that the company have registered. And then you can print this step, or you can go directly to the next step. I will choose, for instance, open innovation, go on with the filling. You can see in this case it's only 20 questions because I have selected only one pillar. Then again, the auto-compile. Okay. You can always review the answer. And after that, in the features that are red, meaning like in a semaphoric metaphor, red, so very bad, or yellow, if I have not something red, the tool will suggest activities like training, mentoring, will mention what kind of activity I could choose. And of course, there are the contacts of the partners at the end. So each company belonging to the country can choose the partner to get in contact with and who can support him, basically. Okay, this was just to give you an insight of the tool. Then I can go back to my presentation. Basically, yes, because we said that everything will be discussed at the end of the section of this training. I have mentioned in the presentation some topics for discussion, but we will see at the end, I think. Like, for instance, and you can start to think about it, if you see features that could be relevant to be added in this tool, what kind of profile inside your company, inside your organization you think would be more useful to involve in this kind of self-assessment. So we can discuss this at the end, and that's it from my side.
Great. Thank you very much, Mara. Any questions? Of course, as I said, we will be having a session during the end of this webinar, and after my presentation, I'm the next one to be following and concluding this first webinar. I hope you can see my screen. I will start sharing my screen, and you can check it, right? You're seeing it in full screen? Everything's fine?
Yes,
perfect. So hi, I'm Panagiotis Katrokazas. I represent the CMO Policy Center, which is a partner to the METAWAVE project. The session here is about identifying barriers and enablers, and assessing the receptiveness and readiness for technological innovations, based also and continuing the presentation by Mara. The main key here and the point of this session is to identify some key barriers for the adoption of the microwave heating technologies, explore potential enablers for the successful implementation, and facilitate an open discussion for the challenges and solutions regarding the strategies for a smoother technology transition. There will be also a presentation regarding the success stories tomorrow, which will be presented by Said, but just a few examples in different domains. For example, in the mining and materials domain, there was highlighted an 85% energy reduction in chemical reactor systems with the use of a microwave-assisted ore processing methodology, and increased shelf life of fruits and vegetables in the food processing domain. So if you can check, there are different examples across different domains with the use of the microwave technology that can be really helpful and provide some meaningful results for a real-world implementation. For example, this specific benefit that was reported in the Research Excellence Framework from 2014 showcased that there was an energy output increase of 2,000 kilowatt hours per ton versus the conventional 685 kilowatt hours per ton, and the processing time reduction was up to 50%. So this led also to a specific reduction in the operating costs for the technologies and for the companies being involved within these novelties. In terms of the organizational barriers, this is a brief overview of how and what types of challenges a company might be experiencing in terms of the use of new technologies. There are 5 categories, and we will be briefly over them within the next slide. So the first category is about management support and leadership, the employee resistance, skills and training gaps, the resource allocation, and the cultural adaptation. In terms of the management support and leadership, these 5 are critical success factors, with most of them being on the lack of top management commitment and limited understanding of technology benefits. So we see here that there is a huge amount of significance being put into how the higher level management and the mid-level management personnel understands what the technology benefit would be from introducing a new technology into their company, and have a clear digital strategy in terms of this decision making. These are all associated with how we can support and provide successful leadership within these companies. In terms of the employee resistance, there are some, of course, common fears regarding of job displacement. We also have this feeling with the recent AI developments where people are afraid of losing their job due to a new methodology or a new tool that is being introduced within their work environment. There are also concerns regarding the wage impacts. And of course, there is also the age gap, which is also associated with the reluctance to learn new systems and technologies within the line of field. Next, this is also associated with what I was describing earlier, is about the skills and training assets. There is limited digital literacy among a lot of people related to these companies and these domains. There is a shortage of qualified personnel and the need for continuous training that needs to be assessed and acknowledged by the personnel that are being involved in management and in positions of matter within this company. There is also a difficulty in attracting new talents and new work personnel within this specific field. So this has to be acknowledged by the personnel and the management that are being working within these domains. And this also leads to the resource allocation regarding what the company can invest and who to invest on, whether there will be a human resource availability, whether there will be a specific infrastructure requirement for the new technology to be being adopted, and what are the competitors are doing within this specific line of field and action. So all of this should be taken under consideration and proceed within careful planning and designing within the strategy of a higher level management personnel. Regarding the cultural adaptation, this is more about the transformation requirements and how this can be changing the management needs and the collaborative spirit within these aspects. One of the key aspects that I would like to discuss about the innovation resistance. More often we see that people are being resisting towards new technologies and new innovative challenges that are being presented to them. So this leads to, let's say, a risk-averse culture that needs to be addressed by the project managers and the ones that are leading these teams. And this has to be taken in mind in order to overcome the traditional mindset barriers and introduce new and meaningful technologies and novelties within the line of work field. As far as the economic barriers are concerned, the point right now is to understand what the financial challenges are, and we are living, unfortunately, in an era where this is more crucial more than ever within the new changes in the economic and the political field. So the company should understand about the initial investment requirements, operating costs, return on investment aspects, the uncertainty within the market, and the financial risks being involved with the adoption of new technologies. For example, regarding the initial investment requirements, things that should be taken under consideration relate to the capital expenditure challenges, including high equipment costs and installation expenses, as well as training investments and system integration costs. So as long as there is a specific training being involved within the adoption of a new technology and everything being explained in a properly and orderly manner, things can be, let's say, assessed within a better and clearer mindset. Operating costs refer to the energy consumption and maintenance expenses. We saw earlier in the previous slides that there is a huge opportunity cost within the energy consumption that could lead to more and lower material handling costs and specialized personnel costs. So the better technology would be and the more introduction could be, it could assist to a better quality control expense, and that could lead also to savings within a specific industry within a domain. And the return on investments relate to the financial performance metrics. This can be assessed over a short, medium, or a long-term period. There is, of course, a payback period uncertainty, but this can be all being calculated and see whether there will be improvements within the productivity and the energy efficiency gains compared, of course, with the competitors in the same market. Some examples regarding how things turned out for companies that were investing in these technologies. There was, for example, and I'm referring to that initial investment of 500,000 euros up to 1.5 million. The payback period was 2 to 3 years, and the energy cost reduction was up to 85%. The key performance metrics that were being also explored within the previous slide was about the processing time, which led to a 50% reduction, and the production capacity that led up to 150 tons per hour throughput. And you can see in the final point about the financial impact that the operating cost reduction was up to 45%, and the maintenance cost savings were up to 25%, along with the carbon footprint that led to 40% reduction in the overall emissions of the company that invested in new technology. About the market uncertainties, there are external economic factors that should be taken under consideration. We saw recently the example with the US putting sanctions into every country related to the market demand and how this produced an energy price volatility. These are things that should be taken under consideration. These are things that cannot be controlled by the project management and the domain and the companies themselves, but they should be taken under consideration when things happen so as to adapt their strategy and design the next steps carefully. There is also the risk regarding the technology obsolescence. So competitors might move towards a new technology. So there should be an investment towards investigating how the new technologies can be adapted within this domain or insurance requirements related to the costs that could put a company into a downtime, as long as compliance expenses related to, for example, the GDPR explanations for a new technology that is being involved and whether it will be involved in data management issues, apart from the technology compliance effects that should be taken under consideration. The final domain of barriers is about the technical barriers. There are, again, 5 key areas that should be explored. The key focus areas relate to the technical complexity, process control, system integration, equipment compatibility, and performance validation. System integration in relation to integration of microwave heating with existing systems refers to the legacy equipment compatibility, whether there should be a modification within the production line, if there is a control system to be integrated, and how the data communication protocols will be affected, as well as the safety system to be coordinated. The technical complexity refers to the new system being parameterized and optimized within the use of the existing industrial setting or domain, whether there will be troubleshooting procedures and the specialized knowledge need among the personnel, or if there would be a need to hire someone that could specifically be involved within the new technology. About the equipment compatibility, the issue here is to ensure the seamless operation between the power supply systems, the material handling systems, and the temperature monitoring ones, if there are space constraints regarding to the new equipment being used, and if there is also the need for an auxiliary equipment that should be purchased or obtained within the factory or the workspace. About maintaining optimal performance, these 5 keys issues are about having a real-time monitoring system, integrate quality control aspects within the current processes, have a performance tracking methodology, and documentations when it is necessary. And finally, the ensuring of the expected results should be compatible and compliant with the quality standards that are being developed not only within the specific company or industry, but also to the energy efficiency aspects and the process consistency that have been set within a national and European level. And of course, have an output validation methodology that should be tracking the performance metrics along the way. So having these key enablers regarding the technical support, the organizational support, and the economic enablers could lead to specific aspects that could be utilized within companies and progress within this aspect. So, for example, in terms of technical support, there could be training programs or viewing of training webinars that could help the support of the implementation, and have documentation resources available in order to be troubleshooting any aspects related to the integration of a new technology within a company. This is about having a professional guidance and have the system design support throughout the way when a new technology is being developed or adapted within a new domain, as long as guiding related to the best practices being involved. I'm not going over all the points. The material will be available after the presentation, so you can all check it and you can see which points refer more to your company or industry, and this can all be taken into account. Training programs is self-explanatory. There could be hands-on workshop. This will be used to be building the competence, among the personnel that is currently being involved with the technologies and the new technologies. And perhaps there could be an issue of having certification programs that could help educate the staff that are being involved. Implementation support is about ensuring the smooth transition from an older technology to a new one with performance testing and quality control setups. This is pretty much self-explanatory, having a documentation and a knowledge base to someone that can refer to back and forth relating to the operating procedures and maintenance guidance, as long as following the best practice guidelines. And of course, have an ongoing support with the 24/7 technical help desk, remote diagnostics, and any other thing that could provide the continuous assistance to help maintain the system at a working level. In terms of the organizational support, in order to enable a successful transition, the key aspects would be to have a management commitment, a clear communication strategy, change of management if needed in terms of the aspects in the resource planning, and of course, performance monitoring. There should be an effective information flow and clear vision and strategy regarding the resource allocation within the industrial domain. At the constant time, there should be a decision-making support and risk management, as well as long-term planning, in order to help the higher-level managers lead into a company and how they could provide new aspects of how they are going to be using and utilizing the new technology within a specific domain. Have regular updates, feedback channels. There should be a progress reporting as well as a stakeholder engagement at all times in order to share the knowledge that has been accumulated through the integration of these aspects. And if that is needed, the transition should be supported through all the cases. So there are some examples that an industry would help pursue a new technology, but this led to management transition. They have to be ready in order to be build a new team that could progress the track and help them implement new roadmap for the company and the industrial domain in order to change the readiness assessment. These are all pretty much valuable inputs and lessons learned from previous companies and examples within companies and industries utilizing new technologies along the way. Also, there should be infrastructure support at all times. This refers not only to the personnel, but also the budget management and the equipment provision regarding providing also training resources and have a new and specific time management related also to the performance monitoring with new KPI, key performance indicators developed, measure the progress and assess the impact during this transition. The last aspect is about the economic enablers overview. So within this aspect, there should be a cost-benefit analysis tool, financial incentives, and performance guarantees related to the adoption of a new technology, and whether a company should invest and fund a new opportunity for their site. Cost-benefit analysis tools, for example, return on investment calculators and productivity impact assessment and the long-term benefit projections. Financial incentives could also be helping to support the implementation related to government grants, tax benefits, if there are energy efficiency rebates, and some funding related to innovations. And this can all be measured along with performance guarantees regarding the energy savings, production efficiency, of course, and system reliability. Risk mitigation should be also taken under consideration. There should be insurance options in terms of phased implementation and a warranty related to the technology and the performance bond that are going to be protecting the investment of a company related to that aspect. Finally, resources could also be enhanced by other options. There are EU funding programs bank financing options and industry partnerships that could be explored, as well as have joint venture opportunities and leasing arrangement with other companies in terms of how an industry or a domain could be utilizing the new aspects of having a new technology being deployed. I think that's all from my side. Sorry for the brief and the overview, but you can all check the material after that. Yeah, that's all me. Thank you for your time and your attention. I'm leaving the floor now open for the question and answer open discussion points. I will bring up some discussion points ahead. So if there are any options or if there are any questions from the audience, we are free to keep. Mara, you can take this time, or Said at the beginning, and you can discuss some things regarding your presentation. So just let me know. Thank you very much. Okay, can I ask if there are any questions from the audience? So the good thing is most likely everything was clear. No need to having, let's say, additional ones. I don't know if I can give some time. We do have a lot of time ahead of us, so. Mara, would you like to take the floor and ask about the tool that you were talking, and then we can.
Yeah, one of the topics that I suggested for discussion is related to the profiles that can be involved in the self-assessment of the company. Meaning, in our mind, when we develop the tool, the profile would be someone, I would say, high level, meaning someone that has a clear overview of all the departments in the company, all the different topics, because it should not be a technical profile only in charge of production, because probably he's not that aware about topics and fields like open innovation or the approach that the company has towards sustainability and circularity. So in our mind, when we developed the tool, the idea that we had was to involve someone from the headquarters of the company, let's say. But I'm willing to hear also for other point of view, specifically someone belonging to a company, whether it's small or big, what you think, or if you think that there is actually someone inside the company that is aware of all the topics that we have discussed, so that can fill in the questionnaire both for the digitalization and for the sustainability and for the innovation culture. So that was one of the points for discussion I was going to suggest. I don't know if someone from the participants want to. And of course, if one of the trainers as well want to participate in the discussion. I mean, for us, it's useful to receive feedbacks. As I said, it's the tool is still in the testing phase, and that's why we would also appreciate if you could register and test the tool. For us, it's useful to receive feedbacks from companies, even if not SMEs, and also from, I would say, different profiles like research center or consultancy companies that have a real connection with the companies and know what they are looking for, what they can do, like also feedbacks on the questions, on the clarity, on the usability of the tool. Everything it's useful for us. So
yes, I will. I'm Julio from Avanzare. I will comment. In our case, this is the roles. Can you hear me?
yes,
Yes, we can hear you.
Okay. In our case, we have divided the roles in two of the C-level of the company. Altogether must be just even over the C, that is the general manager, or even higher is me, that is the executive of the company of the group. But to have all together, I think, or different person from that has part of the roles is more in the innovation is the CTO, and we have also some that for the manager that is in the other part. But over that, yes, a global vision should be the general manager or even over then me. That is the first executive. But this for that we have divided the roles in the C level of the directors, but will be in two of them. But if not, will be even over that. That is our general manager.
Yeah, thank you for the feedback. Yeah, I think that's the like this description applies to most of the cases for SMEs, I believe.
Great. Any other questions, points of discussion? I mean, I can ask something related to how, in terms of the presentation that I made regarding the barriers and the enablers, how do the METAWAVE partners see of them overcoming and how to convince additional, let's say, experts within the field to be in assuming the new technologies and how they could be integrated into their line of productivity and results. So this is an open question to the METAWAVE partners and how do they see them supporting this barrier removal and how they could support the enablers happening within the next line of project. Do we have someone from either Metlen or you can hear me, right? I'm not on mute or okay. I'm not talking to myself. Also, I would like to ask, do we have someone external to the consortium that has joined within this webinar? Or are we all internal to the project?
I think we are, I know, almost internal.
I'm just seeing the names. And
I recognize most of the names.
Yeah. Okay, great. I don't know if Irina Rivero is within us. I'm just seeing the names, just not pointing out anyone, just to see if they were within the METAWAVE project or they are external to it. Irina, can you hear us? No. Or,
Sorry?
yes,
Are you talking
hi.
to me?
Yes.
Yes,
You're
I'm
for METAWAVE, right?
yes, of course.
Okay.
I saw some cases, I mean, from outside the consortium, but right now they leave this the page maybe after presentation they just leave this.
Okay, great. Okay, so let's move on. There's a post survey regarding this webinar. Let me share my screen again.
Just a suggestion, it would be great if we announce this again in for example in LinkedIn or somewhere for tomorrow, because reminding this also would be great.
Yeah, sure. Yeah, we'll take it under consideration.
Thanks.
So for those of you who have been watching, there is a post survey. You can scan the QR code, or you can type in the link in your browser, and you can take it, so we can get some results regarding the understanding of the contents of this webinar. And we will use the survey is anonymized, so there won't be, let's say, any leak of names or personal information, and we will use the results of it into the upcoming deliverable that is related to the specific holding of this webinar. So I'm just giving you some time so you can either type it down or scan the QR code. Okay, everyone. Okay, I would like to thank you all. I don't think so you managed to get the QR code or the link. Thank you all for your participation and for joining. And see you tomorrow. If there aren't any other questions or points for discussion.
Thank you. Have a good day.
Thank you very much.
Thank
Have
you.
a nice day.
Bye-bye.
See you tomorrow.
Bye bye.
Bye bye.
Thank you.